Hi, I'm going to explain you my fifth experiment in Compiler Lab. It is on simulation of deterministic finite automata. So a DFA M is a 5-tuple Q sigma, and this is for a transition symbol, initial state and final state. So let's move on to the program. So this is my program in Java, and this is the part when the program starts. Here I'll be creating a DFA simulator object. This is my DFA simulator object, and I'll be calling, using this object I'll be calling a build DFA function. So this build DFA function is defined here. So this is a build DFA function. It throws an exception. So here I'll be creating a buffer reader object which is BR, and then I'll be having my input for the number of alphabets which is noted by alpha set, and then I'll be give input for number of states for my DFA is denoted by the state set, and then I have to enter all my alphabets of the DFA simultaneously, like example ABAB or AAB or etc. And then I'll be using array list characters for storing the list, for storing an array list character objects from the array into the array. And then I have to create a transition table. I have to enter one by one, like from this state to from a particular state. If I use A or B, so where it will go. Then I'll be using through this for loop. And then final state is created by using the hash set integer. Creates a set of integers which has a resizable array size, and then I have to enter the final states of the DFA. So if the user enters the final states of DFA, soon after he can enter -2 for stopping it. So here I'll be using -2 for that, which is enclosed inside a while loop, and then I'll be calling the DFA test class. So this is my DFA test function, in which I'll be entering my starting state, and I'll be give my input DFA like whatever be it may be AABB, AABB, and I make sure that my input ends with $ or my hash sign. So it indicates that my input will end with this, and I will run a loop at the end of this file, that is a hash. So I will make my caret from index 0 to less than or equal to hash. And then I will increment it, and then so here I will be printing my final state after giving the input, and then I check my final state. If it contains the previous state, then it prints your input string is accepted by the DFA, else it prints the input string is rejected by the DFA. Let's have a look on my output. So please enter the number of alphabets in the alphabet set of DFA. So I make it 2. Please enter the number of states in the set of DFA. So I choose 4. So all the alphabets of the DFA simultaneously. So AB is my alphabets, A and B, and now I have to enter my transition table. So this 2, 1. Then this for the second row, 2 and 3, and then I prefer 2, 4, then 2, 1. So when you're done of giving inputs, enter -2 to stop filling, like after which I have to give the -2. So I'll be choosing my 4 as my final state. So after which I'll be giving -2 to stop it. Now you can see 4 is mentioned as my final state. Now enter the starting state. So starting state, obviously it will be 1. So now give input to the DFA, and I make sure that my input ends with hash symbol. So my input symbol be AABB hash. So you can see that the final state after giving the input is 4. So my input string is accepted by the DFA. So this was my 5th experiment. Thank you for watching my video.